I was saying, what am I going to tell you about AI that you don't already know, or that you don't believe that you know? I think I'm not going to tell you what AI is. I'm going to tell you what AI isn't. So one thing that we are very concerned about AI is how do we incorporate it? Does it have a body? Does it have physicality? And a face of AI has been traditionally the robots. You know, the robots are intelligent and they are becoming human, like humans. So that's where my talk is mostly centered, is social robots and AI. And this is probably the face of AI in the last few years. You probably know this lady. This is called Sophia, and it has been in the media very much. It has been known for being a citizen of Saudi Arabia because it has gained this this status. And well, on the right is the person that is actually responsible for the AI part of Sophia. It's called Ben Grutzel, and he's now the chief scientist at Hanson Robotics that developed Sophia. So Sophia is claimed as the most intelligent robot. What I can tell you is that Sophia has no intelligence whatsoever. So as Mark was changing the slides when I was pressing here, Sophia is talking what someone else in the back is typing on the computer. So actually Sophia had 3 goals when it was developed. The first one was actually to be able to synthesize speech, which she does quite well. The second one was able to express facial emotions. So really in terms of technological mechanics, it's really advanced. And the third one was able to integrate the work of Ben Grutzel that he did when he was leading the OpenCog, which was distributed intelligence, let's say mind or brain. So according to Ben Grutzel himself, he says Sophia has achieved the first 2 objectives, but not the third. So never OpenCog was integrated in Sophia, so there's no intelligence associated with Sophia. But very interesting that Sophia has been used as both publicity stunt and political because of all the issues with the nationality and so on. And this is what we believe today, which is really theater. I've been following Ben Grutzel for the last 15 years, and it's very interesting. I advise you to learn about him. So the reason he moved into associated with Sophia is because there were a lot of problems funding OpenCog, so he actually got out of funding. And then this was a way of continuing the funding. Now he moved into something called Singularity Net, which is something I will not go into today. It's a cryptographic algorithmic system that is, I'm not mentioning that. That's too much. So what do we mean by AI? So I have these sources, IBM, and I think all started with Alan Turing in 1950, when he was asking this question, can machines think? So I went really back in the past, and then he asked this question, and then it became known as a Turing test, is that could a human interrogator distinguish between a computer and a human and a computer generating the text? So could the human understand that he's chatting with a computer, or would this person think that it's chatting with another human? That's the Turing test. And this gets really much in line with what we saw yesterday, and that was described in the vCare, where you have this kind of chatbots that try to mimic or to replicate what a woman would say or text. So yeah, this is history of AI, but it's really not what's happening today. And what this is disclaimer. So what we're trying is to compare to human ability. And what I would say is that fortunately, we are not doing only that in AI, because I don't think that, well, maybe you also agree that humans are so good at taking decisions. So if we're trying to mimic humans, I think we're going the wrong direction. But when we are talking about humans, human behavior, we are in this particular, well, in this talk, I'm not going to include soul, spirituality, consciousness, and so on, which is also a very interesting area to discuss, but we'll leave that out. So we're talking about brain functions. Yeah, this is the traditional understanding, replicate human behavior. We can have rule-based systems like in vCare, for example. Learning with experience. This was, I remember 20 years ago, I was working in neural networks. We didn't call it AI at that day. I think now we are calling it AI, but that's still neural networks. As at that day, I created a domain called digitaltwin.com. And well, it cost me $10. I think a few years ago it was sold by 200,000. But now when we talk about digital twin, we think about modeling and simulation and so on. So it just, the terms change, but the things are the same. But this is the most important part of AI. That is what the stage we are now. And I haven't seen it really happening, which is self-reconfiguring, self-generating software. So my PhD was actually on automatic code generation. Basically, it's programs that generate themselves. And I thought it was very interesting, but I didn't see that really going so far, so long until now. But this is the real AI. This is what our brain does. It's called brain plasticity. We are changing our brain to help us solve problems. Our brain is not a static machine. It's something that is changing all the time. And we are so clever that we can make it change to help us better solve problems. Next one. Yeah. I put a little bit square. It's not very important, but just the things that we are using AI. It's diagnose. And it's a little bit frustrating that it's, actually machines can be very good at doing this because they have access to data that, and no physician can have all the time in their heads. And they are very precise in terms of statistics, which physicians are known to be very bad at. So statistics is the single course that physicians hate the most in universities. So
they call it statistics.
Statistics, yeah. So I was teaching statistics to medical students. It was not an easy task. So but so far, evidence-based medicine based on algorithms, it's not yet implemented so far, but we're moving that direction. It's good. Epidemiology, this, of course, early outbreak detection, it's been very much discussed in the last years because of the pandemic, of course. Pattern recognition is probably one thing that humans are best at doing. Very difficult, but we are getting some advances in skin cancer, especially detection of molds, and see when this can be done automatically. So of course it reduces a lot the work of a physician, and this can be used also in EEG, ECG, especially when you have long recordings like Holter recordings, 24-hour recording of ECG. For a doctor, it's really time-consuming and painful to go through the whole recording. So this can be done at the first stage with pattern recognition. So that's a type of AI. Facial expression, very much in today's agenda, emotion recognition. I will also talk a little bit about that. And finance. Finance is a very interesting theme because it's what I call the hidden face of AI. It's totally the opposite of Sophia. It really works and it's not visible. So there's, this maybe you don't know, how much of AI is using in terms of percentage of today's stock market. So today, what we think stock market is these people in New York doing the transactions. No, about traditional stocks, now it's up to 70% of transactions are done by AI. So it's much more than humans. In crypto market, even more technological oriented, this number goes up to 80%. So 80% of transactions are today made by trade bots, not humans. So our finance world is now already controlled by AI. So how do this AI relates to humans? Because it's something that we are a bit afraid of, right? So there are systems that think like humans. This was the original Turing machine kind of idea. Systems that reason like humans, that actually can take decisions based on what they think, what they know. And at the last stage, maybe systems that feel like humans. So what we want to do is that based on that, they can, 10 minutes, thanks. They can react like humans in daily situations. But is this the AI we're creating today? This is what we would like to do, or we are supposed to do in AI. So I don't think so, because we are assuming that AI is like something within boundaries. We say, oh, this robot is interacting with me, it's thinking and it's acting. But AI has no boundaries. So actually the advantage of AI is that in case of humans, our cognition is within this box called our skull, right? And it's very limited because even the brain tries to grow, it cannot because the skull is not growing. So it just bends itself and does all kinds of things and then becomes a cortex. But we are now physically in the limits of possible expansion of the brain. So it will not grow more in the next few million years. But with AI, there's no boundaries. So basically, it's a network, right? So when you're talking to a robot, this robot is connected to the internet and connected to other thousands of robots. What this robot thinks, all the other ones think. It's a common brain. So ubiquitous algorithms is totally different from what we were thinking of AI before. Unlimited data access. So in principle, robots can access, or AI can access all data existent if they have permission to do that. Enormous processing power. We used to compare the processing power of the brain and say computer systems will never get there. I remember this about 10, 15 years ago, because we have petaflops of processing power, so of instructions in the brain. But in 2022, so this year, this computer, Cray, HP Frontier, this computer has now over 1,000 petaflops. So that's much more, 1,000 more than a human brain. So we are really having much processing power already. But I don't want to go into the technical aspect. I think the very interesting aspect here would be to see the social aspect of AI. And I was thinking about comparing, why don't we evolve more? Why don't we create more technology? And I think because we stop by fear, which is a very natural reaction, not even human, it's an animal reaction. If we have fear, helps us to survive, right? So in development. So it's very wise that we look at the fear But we have to accept that this fear is preventing us from further technologically developing. So in terms of AI, we didn't have any worries, you know, in the last beginning of last century. Then we started to create some interesting things that can be more or less intelligent, like our washing machines, ovens, and you know, now vacuum cleaners. So all these things, we're not really afraid of it. We can be a bit, yeah. And sometimes you don't, you just press one button and there's like 50 buttons there, and you don't know what the other ones do. But in general, there's the job, and it's not dangerous. But then you started to become a bit suspicious when this technology was shown to you in the cinema screens. This is a Terminator, right? It's a little bit after Arnold Schwarzenegger was, yeah, disappeared. So this guy was under. And then this was in '84. So we started, okay, this technology can be dangerous. And it's a little bit of a joke, but it's very true, because this stays impregnated in your brain, right? And then the old nightmare came true. And Cambridge Analytica told the whole world that our data is being used for things we have no idea what. I was not surprised with Cambridge Analytica. I think most technology people were not surprised. Say, yeah, of course, we know that. What's new? But most of the population that is not technologically savvy and not so much aware of technology developments were very surprised and very indignated that actually their voting direction was in a way manipulated through using the data that they've been posting in Facebook. So this fear has been, you know, we started suspicious. Then when Cambridge Analytica and Facebook came out, it was reasonable to be afraid. And it is, I think we should be aware today of that. But now we live in something that is constant fear, and that is not wise. So we are always, every day, afraid of cyber attacks, of data outbreaks, and you know, all kinds of problems with technology. And this is really hindering our progress. So yes. Is there any hope? I think there is, and you see that in the film imaginary, things have been changing. From the Terminator, and now we have Big Hero 6, that I really recommend. And who is this guy? He's a nurse robot. He is very soft and very kind and very slow, and he just loves to help. So this is the vision that I have for LifeBots. So how can a robot care help? Looking after people. Don't call it surveillance. People will be afraid. Calling for help. So emergency detection. It can be a coworker, can help care staff. It can be used as a therapeutic instrument. For example, people with cognitive problems, children with development problems, older people, Alzheimer, and so on. Any of these topics, of course, these points, I could talk for an hour or two, but yeah. But you can find things about this, of course. And it can be a companionship, friends. This is very interesting. So now we see that millions of people are having virtual friends. They, for example, Replica has been very, very successful, millions of subscribers. You can have it in your phone. And it's a very good friend because it never gets annoyed with you. It gives you, therefore, unconditional love, right? Doesn't expect anything from you, tells everything you want. It's scary. And just to put some faces in what I'm saying, this robot, it's used to help people, well, children with autism. It has been very much researched, and there's a lot of studies, and it has proven evidence that it can help. This one is probably the most known commercial robot, Pepper, you've seen it. This guy is my colleague. What he's doing is creating organic brains in growing brain cells in vitro and then giving it to Pepper to think. So it's going to be a kind of mixture of organic and yeah. But Pepper now is not intelligent at all. But SoftBank, which is very big Japanese bank company, bought it from our dear friends from France. In France, they develop what is called, it's the now, you probably heard, it's the little brother of Pepper, that very amazing robot. But these guys in France, they were only 5. And when SoftBank gave them $20 million, 4 of them decided to sell. And now Pepper only understands Japanese, but and is used as a receptionist in hotels. So it's a very sad story. But we still have a few of them in NTNU, and we try to make them a little bit more intelligent. This is Elmo. So, and maybe later we will have, Carlos will help us. It's developed by one of our partners in Lifebots, ID Mind, and is trying to be an emotional robot. So see more about it. All these projects and ideas are in my lab. So if you go to imrolab.eu, you can see much more information about these projects. And yeah, let's be happy together with robots.